Okay, just a few National 5 electric circuits things that I'd like to discuss with you. And if I do it as a video, I'm hoping you can access it as you need to. Now, some of you have still got to work on Ohm's law, some work on power, section 13, and then there's some interesting challenging questions in section 14. But the bits that I want to really discuss with you and try and explain are out with that. They're really things like LEDs and potential dividers, which I think are a little bit more confusing. So I'm going to start off by saying you really need the basic voltage rules in every situation. So let's say I have a 6-volt battery here, which would normally be made of 4 1.5-volt cells put together. Then these two voltages would have to add up to 6 volts. So it'd be perfectly fine for me to have 5 volts and 1 volt. Excuse me, but that could have been 2 volts and 4 volts. It could have been 3 volts and 3 volts. It depends on these bulbs. These bulbs are obviously different because they're going to have the same current flowing through them as it's a series circuit, but they have different power. So this one must be giving off a lot more energy. It's got more voltage. In a parallel circuit, if I had a 6-volt supply here, then it's really important that you know that this bulb would get 6 volts and this bulb would also get 6 volts. So in a parallel circuit, each branch gets the supply voltage, and in a series circuit, the devices, whether they're resistors or lamps, share the supply voltage. Now, what I want to do is skip on to the LED, because an LED is something that's covered in section 20 before you start potential dividers, and I wonder if it'd be best to do it in sequence. Now, starting off with an LED, this is the symbol for an LED, and a light emitting diode is one type of diode. Now, if you connect it up into a circuit, so if I just make this up into a circuit, and I have the positive side of the battery here and the negative side of the battery there, then if I can imagine positive charge coming out of the battery, out of the positive side of the battery, going around, and it meets in the direction of the arrow, then we say that is positively biased and a current will flow. If I connected the battery the other way around, so that positive charge coming out of the battery, positive charge would come around and meet the wall, then no current will flow. So this works and you get current flow. This, you do not get current flow. And we say this is forward biased and reverse biased, but I don't think you need to know those terms. So all diodes only allow a current to flow one way. And having looked at this, you could try section 19 on LEDs, question 1. But I really need to go on to question 2. So the key thing with these light emitting diodes is that they're very sensitive and they can only handle small currents, like about 10 milliamps, and usually small voltages like 1.6 volts, 1.8 volts, 2 volts. Okay, so I should have put a voltage in there. So 2 volts would have been something around 2 volts would be appropriate. So what happens with them and how do things work out? So what I've done here is I've started an LED circuit, and you can see that I start off with my 6-volt supply. Can I just zoom in a tiny bit to make that a bit bigger? If I start off with a 6-volt supply, now my LED only wants to have 2 volts across it. Okay, now if you look at this, I've set it up with the positive side going round in the direction of the arrow, so that's looking good, so we'll get current flowing. And because it's a light emitting diode, it will give off light, which is what the little arrows represent. Now I need to use up 4 volts, and how can I do that? Well, the answer is I need to have a resistor in this circuit, which is going to have a voltage of 4 volts across it. Okay, so that's what I need. So that sorts that out. But the LED that I'm told about in this particular case can only have 2 volts and 10 milliamps. So that's 0.01 amps. So I know that all the way around this circuit, it's a series circuit, the current will be the same everywhere. So the current through my diode will be the same as the current through my resistor. Now this resistor is going to protect the LED from getting too much voltage and too much current. It can't handle the 6 volts. So this is a protective resistor. And all LEDs need a nice protective resistor to look after them. So here's my protective resistor. What do I know about the protective resistor? Well, I know that ideally it's going to have a current of 0.1 amps. So in the resistor, I know that to make my LED happy, I only want 0.01 amps at any point in the circuit. Well, because there can only be one current in a series circuit, the same current everywhere. And I know that it's got 4 volts across it. So it's very easy to say, how do I design or choose this resistor? I go, okay then, well, using V equals I times R, the resistor that I need, the R, will simply be what I get if 4 equals 0.01 times R. So the 0.01 is times on this side, so I need to divide on the other side. So if I do 4 divided by 0.01, I get my resistance. And of course, 4 divided by 0.01 is 400. So I now know, which I didn't know at the start, that to protect this LED, I need a 400 ohm resistor. Now, that's pretty much all you need to do about LEDs. And if you look at the questions on the, so I thought it was then the questions are like this, where it says, for each of the following circuits, you're going to find the protective resistor. Okay, so I'm in section 20, question 3, and I think those questions can all be done using exactly this method. Okay, I now realise that I've just gone slightly out of view. I do apologise. So to finish off that maths, I just did the standard Ohm's law equation, substituted in the numbers I had, and got to 400 ohms. Right, I'm going to stop that and call that my LED video, and I'll do the next section, section 21, in another video.